There are two common logarithms that appear frequently in application problems. We'll also be looking at these types of logarithms in the next two sections when we want to study both the properties of logarithms in more detail and also solve logarithmic and exponential equations. These common logs are also used in manners of convenience, so let's go ahead and define them. The first common log that we're going to introduce is the log base 10. This is referred to as the common logarithm, or just the logarithm. And when we're using this, all we do is we drop the base and we assume that it's 10. The other logarithm that we're going to introduce is the natural log. And the natural log is going to be denoted ln of x, which is equal to the log base e of x. Let's go ahead and look at some application problems and more examples. Example 5. The amount of time to double the amount of an investment at an interest rate r compounded continuously is given by the equation t, which is time in years, is equal to the natural log of 2 divided by r. Let's find the required time to double an investment at 0.9%, which is our interest rate. T is going to be equal then to the natural log of 2 divided by 0.9%. Now we need to go ahead and rewrite this as a decimal. This is equal to the natural log of 2 divided by 0.009. Using a calculator, our natural log of 2 is approximately 0.691, this should be a 3 here, then a 1, 8 divided by 0.009, which is approximately 77.016 years. So this interest rate is terrible because at this point, inflation is going to give you more money than your investment, which means you're going to just lose money because you're not getting at least the inflation rate. Example 6. Let's go ahead and find f of g and g of x given the following functions. F of x in this case is 3x, and g of x is going to be equal to an x squared plus 1. First, let's go ahead and find f composed of g. This is going to be equal to f of g of x. G of x in this case is our x squared plus 1. So plugging our f squared plus 1 into our 3x, we're going to get that this is equal to 3 raised to the x squared plus 1. Part 2, we need to go ahead and find g composed with f of x. This is going to be g of 3 raised to the x. This is equal to 3x raised to the second power plus 1, which is equal to 3 raised to the 2x plus 1. Next example, example 7. Let's go ahead and find the inverse of the following function. Rewriting our function real fast, we're going to get that this is y is equal to e to the x divided by a 1 plus e to the x. Multiplying both sides by 1 plus e to the x, we'll get our y plus y e to the x is equal to e to the x. Let's go ahead and subtract both sides by a negative y e to the x. This leaves us with y is equal to e to the x minus y e to the x. Now we have an e to the x in both terms over here. We can go ahead and pull it out. Then dividing both sides by 1 minus y, our equation becomes e to the x is equal to y divided by 1 minus y. Let me write this again on a new page. Since we're trying to find the inverse of our original function, we needed to isolate x on one side. So now, by definition of a logarithm, the equation on the left-hand side is equivalently going to give us the equation on the right-hand side. X is equal to the natural log of y divided by 1 minus y. Flipping our x's and y's, we find that f inverse of x is equal to y. This is equal to the natural log of x divided by 1 minus x. Example 8, let's go ahead and practice finding the domain of a composition of functions. Find the domain of f of x is equal to the natural log of x minus x squared. Let's go ahead and recall that the domain of the natural log of x is all numbers that are greater than 0. Then that means that the natural log of x minus x squared is only defined when x minus x squared is greater than 0. Since we need the argument to be greater than 0 by this first part here. Let's go ahead and look at the graph of x minus x squared and figure out where the x-intercepts are. To find the x-intercepts of the graph of x minus x squared, we're going to set this equal to 0. 0 is equal to an x minus x squared. Pulling out an x from both terms, we get an x times a 1 minus x. Either then x is equal to 0 or x is equal to 1. In the graph of y is equal to x minus x squared, then this is going to intersect at x is 0 or x is equal to 1. Since we have this negative in front of our x squared, that means that the graph of our function is going to be pointing downwards, like this. That means the only portion of our graph which is going to have positive values occurs between 0 and 1. What we get then is that our x values are going to be less than 1 but greater than 0. And this is the domain of f of x.